Hi everyone, and welcome to a new episode of Global AI Notes, the show by the global AI community about everything AI. And today we will talk with Carlotta. Hi Carlotta, welcome to Global AI Notes.
Hi Hank, hi everyone.
Hi, super nice to have you. Can you introduce yourself and tell us a little bit about who you are and what you're going to talk about today?
Sure thing. So I'm Carlotta Castelluccio. I'm a cloud advocate at Microsoft, and I'm focused on artificial intelligence and machine learning technologies. So I guess I'm the right show, right?
Exactly.
And yeah, today we are going to do a deep dive on natural language processing, and we'll reveal a bit behind the scenes of this technology domain. So looking forward to it.
Great. Let's not waste any time and start your presentation. You have already showed your screen. I'll put it in the stream, and the stage is all yours.
Awesome. Thank you so much. So welcome again to this session about natural language processing. As I mentioned before, we are going to do a deep dive on this technology domain and reveal a little bit behind the scenes. But before doing that, let me just give you an overview of the AI landscape today in 2023. Um, so I think we are living in a pivotal moment for AI, where AI assistants are not limited anymore to perform repetitive tasks like doing a phone call via voice command or retrieving the shorter path to get somewhere, right? Um, I think people were quite used to this kind of AI capabilities, but now we're living in a time where chatbot like ChatGPT, empowered by the so-called generative AI models, are able to compose an original poem or a rock song. They are able to write an article or even a book. And other AI-empowered assistants like GitHub Copilot, for example, are able to do pair programming with a human developer, providing inline suggestions in multiple programming languages, answering code-related questions, helping with bugs, troubleshooting, and fixing. Um, in other words, AI assistants reached human parity, or they are very close to it, for a much wider range of creative tasks, causing excitement and interest in a global audience, but at the same time also causing concerns for the social implications and huge transformation that our society should be ready to. So I have a strong belief that there's only one way to fight fear, and this way is awareness. So the main objective of today's session is to reveal what's behind the scenes of these magic tricks, um, which are anything but magic, though. In a simple way, we have just 30 minutes together, so but I'll do my best. And also we will see how we can lean on the power of these cutting edge technologies. But to do so, so to achieve this learning goal, first of all, I need you to know who this guy is, natural language processing, or NLP, since jigs like me love acronyms. So in fact, generative AI models are often used in this AI domain, natural language processing. And when I say natural language, it could be intuitive, but it's no more than the human language. What we call natural language is just any language human speak, basically. Um, and all the examples I've done before fall under the umbrella of natural language processing solutions. So an AI, machine learning solutions able to process textual input and to give as output, again, a text in human language. But before sharing with you just a definition of natural language processing, let me do an example. I think that things look easier when you do practical examples. So let me start with an example. And let's imagine we are about to leave the office for a 1 week vacation, and we would like to find a smart way to handle the huge amount of unread emails we will get at our return. So in simple terms, we would like to find a way to label the unread email, the unread emails at our return as spam or junk email and not spam, or worth reading and not worth reading. So it's not the first time we found ourselves in this situation. So what we could do is looking back to the past, looking back to the history of our inbox emails that we already have split into two folders, spam and not spam, and look for some characteristics that helped us understand if the email was a spam or not. And after some time we do this job, we'll start seeing a pattern. For example, emails with a short body, with lots of punctuation in it, or using the term now or urgent are likely spam. Of course, I'm oversimplifying this, but it's just an example. Now, this pattern could be then applied to new and unread emails to predict if it's worth reading or not, that email. Of course, if I do this manually, I wouldn't get any benefits, right? But here's where teaching a machine to do this job for us comes to the picture. And the example I've just done is called text classification. And in particular, it's a binary text classification because we have two labels, worth reading and not worth reading. Now, text classification is a typical classification problem pertaining to text sequences. And text classification is just one of the thousands of applications of natural language processing. And there are also some more complex kind of classification. As I say, this is an example of binary classification, but there's cases where a binary label is not enough. For example, you want to categorize your email in multiple classes like complaints or bills, and then personal emails, etc. But I think this is still a good way to start thinking at natural language processing, a machine processing a text and doing something with it. So let's zoom out a bit now. Let's look at the bigger picture. In this awesome graphic taken from the AI for Beginner open source curriculum, that it's a great resource for learning not only natural language processing, but also other AI applications, AI domains. So I encourage you to check it, and it's for free. So in this graphic, you can see that you have text classification here listed together with lots of other machine learning applications in this domain. So the definition I wanted to share for natural language processing is that this is a domain of AI enabling machines to both process, then interpret, and even generate human language as it is written. That is named, as I mentioned before, natural language. In addition to text classification, there are other applications of this domain. For example, you can do sentiment analysis, which is a typical classification problem where we need to attribute a score, number, corresponding to how positive or negative the meaning of a sentence is. You have named entity recognition that refers to the problem of extracting certain entities from text. For example, we might need to understand that in the phrase, I need to fly to Paris tomorrow, the word tomorrow refers to a date and Paris to a location. We have text clustering, for example, that can be useful when we want to group together similar sentences, or for example, similar requests in technical support conversation. We have text summarization, which is a technique that enables computers to read long text and then summarize it in a few sentences. And we have text generation that we are getting familiar with models like ChatGPT, which is the ability of a model to generate new text starting from a textual prompt. So we are talking about the type of task we have seen in the first slide, basically. So there are lots and lots of possible applications of artificial intelligence in this domain. But the main thing is that machines are able to process a text in input and in some cases generate some text in output written in natural language. Now, let's zoom out again, because artificial intelligence is so huge that it's important to find your way around the labyrinth of AI terminology. So you see here an onion with multiple layers, basically. And with NLP, we basically are in this layer here. But let's go by step. Let's start with the larger onion layer, AI, so artificial intelligence. Artificial intelligence is the name of a whole knowledge field whose aim is to explore the possibility to create machine able to mimic some of the human cognitive capabilities, like to talk, to write, to hear, to make decisions. Then, at the second level, we have machine learning, which is a subset of AI. And it includes a collection of algorithms able to extract patterns from the data used for the training, and then apply the same pattern to unseen data. We've talked, for example, of retrieving the pattern to recognize an email as spam or not, and then applying to unread emails. And then we have another subset, the deep learning subset, which is a modern machine learning method based on the neural network architecture that we'll see in a moment. And deep learning algorithms, differently from classical machine learning, require larger data set and a greater amount of time and compute capacity to be trained, and are more powerful, not only in terms of performance and accuracy, but also in terms of complexity of the data they can handle. So, as I mentioned before, natural language processing sits on this onion layer, in a sense that the modern cognitive services addressing natural language processing tasks, like the ones I mentioned before, are based on deep learning algorithms. And to be precise, some of the tasks we have presented before, like content generation, are unlocked by a subset of deep learning models called foundation models, which is basically another name for generative AI models. So these models are able to perform some tasks like text summarization or text entity extraction with a greater accuracy. And they are also able to unlock new possibilities like content generation that wasn't possible before. But how did we get to this point? Let me do a little bit of history here, because again, this may look like magic, but we didn't arrive to this level of technology in one day, right? Natural language processing is not so new. If we think that the first projects in the natural language processing domain date back to 60s, when the first researchers began to explore the possibility to create machines able to replicate some of the human cognitive capabilities, like the conversation. And this led to some important successes, such as Eliza, which is the first typewritten chatbot acting as a psychiatrist. This used a so-called symbolic reasoning approach, which basically means that you represent the knowledge in a knowledge base, a knowledge from an expert in a knowledge base, and then you keep this knowledge base accurate and up to date in a way that you can keep answering the questions from the user of the chatbot. It's quite intuitive, at least today, that this approach is not scalable. And this led to the so-called AI winter in the AI research field in the 1970s. And the turning point arrives during the 90s with the technology evolution of the hardware, which became cheaper and more capable to handle large amounts of data, together with the creation of new algorithms classified as machine learning, as we said, able to learn patterns from data without being explicitly programmed with instructions. In particular, new statistical models, what we called neural networks, gave a boost to the AI research development. And they also benefit from the availability of more powerful type of elaboration unit, the GPUs. Now, the modern virtual assistants born in the first decade of the new century, like Siri, Cortana, or Google Assistant, are also built upon language models based on neural networks. They are very proficient in identifying a specific need in the input request from the user and then pair it with a suitable answer that could be retrieved via web search or could be retrieved in a list of predefined answers. Now, generative AI, which includes natural language generation, is the cutting-edge technology in this field, and this is able to generate examples starting from a huge amount of data used to train a model. And when I say huge, I think about all the information on the internet, so really huge. And that's why we talk about large models, because of the amount of data used for their training, and also because of the number of calculations they are able to handle. And they are all based on a new neural network architecture that we are going to deep dive in a minute, which is called transformer. So now that we know a bit of history, let's go to the core of our session today. And let's deep dive into how a machine understands a sentence. First of all, let me introduce you to the neural network architecture, because I mentioned it, but I want you to look at it. So this is inspired by the structure of the biological brain, made up of connections of nodes that we call, in biology, we call neurons. And the way this works, in simple terms, is that each node making up the network is activated or not by an activation function calculated as a weighted sum of the inputs to a neuron. Now, in the natural language processing domain, the weights embeds the semantic value of the text. And as you can see from this graphic, this network wants numbers in and numbers out. So the first problem to solve with natural language processing is that we have text to process. So there are three fundamental steps to do this conversion, let me say. So starting from the text, having a bunch of numbers. And again, let me use an example here. We have this sentence. He had tea and she drank iced coffee. And we want our machine to be able to process this sentence. So first of all, what we should do is split this text into smaller pieces, which are known as tokens. Now, a token is a dimension which varies from a language to another, and usually is a dimension between a character and a word. But to make things simpler, in this explanation, we'll be using the terms token and the term word interchangeably. So once the text is split into tokens, we can build a dictionary such that every word is mapped with a number. And there are lots of multiple algorithms that do this kind of stuff, which are called embeddings. And create those mappings, for example, taking into account the frequency of each word within the text. Then the second step is defining a standard length for the embedding space, which means defining a standard size of the vector which will be representing my text. And in our very simple example, let's set this dimension to 10. That means we want to convert our text into an array of 10 numbers. And we are going to fill this array by collecting the numbers mapped to the tokens in the order they appear. And then if the input text is shortened than the predefined standard dimension, as in my example, the rest of the array, in this case, just the last item of the array, will be populated with a placeholder, for example, 0. Now, once my text has been converted to a standard length of the array of numbers, in this case, this array of dimension 10, I'm ready to train my neural network. And the outcome of this training process is a space called semantic space of dimension 10, so the dimension I've chosen at the beginning, where the tokens of my input text are represented grouped into clusters of similarity, such that words or text with similar meanings are closest one to another in the semantic space. For example, starting from our initial sentence, words like he and she will be closer one to another in the semantic space, or words like coffee and tea will be again closer into the space. Of course, here you see a representation of the space in a two-dimensional space, just because it's the most intuitive way for us to represent and understand the reality. But imagine this is a 10-dimensional space. Now, it's easy to grasp as representing words in a semantic space in a way that similar words are in proximity one to another is not enough to represent the whole meaning or a sentence or a text. And the reason is that context matters. For example, the same word can assume a different meaning according to the context in which it's used. And this is especially true for the English language. Let's take this sentence, those two sentences, she had coffee versus she had strength. So had here has a very different meaning into the two sentences. And so it is true that in Italian, for example, you would use two different verbs for the same term. But how are we able to tell that the two terms had have a different meaning in the two sentences? Based on the context, which in this case means based on the word following the term had, coffee in one case and strength in the other case. And this means that we need to convert the words into ideas such that the two had are represented in the semantic space as two different items. And the semantic proximity is not computed only on the single term, but on the idea, so on the more complex concept. Once we encoded my collection of words into a more complex idea inside the semantic space, it's also possible to decode it into the desired output, which varies according to the main application. In this case, we have a machine translation example. So this is exactly how the recurrent neural networks, which are the mostly common used in the natural language processing domain, work. And they process collection of words included into a predefined linear window, shifting throughout the text as the model reads and analyzes it. But at this point, you can argue that recurrent neural networks are not so new. So if those models were already able to do those type of computation, why the newest large language models are so revolutionary? I'll tell you. It's because of the transformer model architecture. So the main limit of recurrent neural network is indeed the concept of the basis of how they work. So a recurrent neural network uses the so-called immediate context, which are a few words around the term in analysis. And what's the issue? Let's imagine that we have this sentence. Mary already had coffee that morning, so she didn't accept a cup of iced coffee his colleague offered her. And let's imagine we want to answer to this question. Why didn't Mary accept the coffee? Now, to answer to a question like this, our model should be able to correlate the expression didn't accept the coffee with the subject she, and then the subject she with Mary, covering a quite long window of words. And this is still possible with the recurrent neural network, but greater is the dimension of the window, greater is the complexity of the model, the cost of its training, and the probability of error. So again, this is not scalable. And that's where the transformer model comes into play. And the invention enabling the revolution in the deep networks domain has been the mechanism of attention. Again, this is inspired by the cognitive capability of the human brain of giving a different weight to the input we receive, such that we can focus, for example, on a voice speaking to us and isolate it from a noisy background. Similarly, the basic idea of the deep network attention mechanism is that each time the model tries to predict an output word, it only uses parts of an input where the most relevant information is concentrated instead of the entire sentence. So a new neural network architecture has been built upon attention mechanism called transformer, and this architecture is basically what enabled the availability of new models called foundation models. We have mentioned that beforehand. And that's also what the T in the GPT acronym means, transformer. So the newest foundation models are machine learning models trained on a large amount of unlabeled data from diverse sources, and then adapted to a wide variety of tasks. So basically, these models capture general patterns and structure of data and aim to replace task-specific models by unifying different tasks into a single model. So if before we should have a model for question answering, one for sentiment analysis, one for information extraction, now we can have a single model able to do all of these into a single solution. And they are capable of executing tasks they are not being trained for. And also the user is able to interact with this kind of model, again, with natural language processing. So in English, for example, or in the language they speak. And they do that by using an input which is called prompt, and sometimes also giving some examples of how they expect the results from the model. And in this case, we talk about few shots learning. But now let me, before concluding and pause for a few questions, let me conclude by saying that I think that responsibility builds on awareness. I've mentioned this beforehand, and that's why I wanted to reveal or demystify a bit natural language processing. The output of an AI model is not perfect, and sometimes the creativity of in particular the generative AI models can work against them, resulting in an output which is a combination of words that the human user can interpret as a mystification of reality, or it can also be offensive. So let's recall that AI is not intelligent, at least in the more comprehensive definition of intelligence, including critical and creative reasoning or emotional intelligence. Generative AI is not deterministic. We can get different outputs for the same inputs, and it is not trustworthy, since hallucinations such as erroneous reference can be combined with correct information. So, and also presented in a persuasive manner, making the identification difficult without close inspection. But knowing those limits, we can also be able to mitigate them and go beyond. We have a few tools to mitigate the impact of hallucination of or erroneous or unexpected outputs from AI. For example, we can design effective prompt, enabling the model to customize the answer for our scenario and our users. We can provide through prompt validated data source and ask the model to cite them. We can also tweak the parameters for the models like temperature, which handles the degree of randomness, or the length of the output. And we can also apply content filtering to detect misuse in the input to the model or the output of the model. So we have tools to mitigate these. We have tools to go beyond the limits. But again, I think that all of this is based on awareness, on the knowledge of how all of this works. And I think I will pause a bit now and see if there's any question. I think there's no questions in the chat, but if you have any questions, I'm happy to take them now.
Cool, yeah, there are indeed no questions in the chat yet, just some good mornings and hellos and so on, a lot of likes on the session, but nothing, no question. But I do have a question for you.
Yeah, please go ahead then.
What is the last thing you used these models for? What did you do with them?
I think the last thing was use it in a chatbot for a chatbot solution. I'm fascinated by the conversational domain. So in the natural language processing domain, I'm fascinated and passionate about the conversational the conversational application. So yeah, that was my last demo or project, I would say.
Cool. Nice.
And I also have some maybe some tips from some last tips for the audience in terms of how they can learn more about natural language processing and also reinforce the AI skills. So I mentioned it beforehand, a curriculum. We have an open source curriculum you can lean on to learn more about natural language processing, but also computer vision and other applications of AI. And then if you are also interested about some cognitive services based on natural language processing technologies on Azure, You can explore them on Microsoft Learn, and also learn how to build natural language solutions with Azure OpenAI Service, for example, that combines some of the most powerful models into a platform. So I just collected some useful resources that hopefully can be helpful for you to learn more on natural language processing and AI in general.
Cool, thank you. Yeah, especially that AI for Beginners course is a really, really good one. I think a lot of people already followed it on GitHub, contributed to it, and it's a very popular repository, I think. And you kind of nailed it. I think also the cool drawings you showed in the beginning are also in that repository.
Yeah, exactly. And that's lots of sketches in that repository. That's one of the added value, I think, of the curriculum. I love the visualizations.
Yeah, that always helps me to kind of, I need to have these concepts visualized, and I think they really did a good job in making those illustrations. So
yeah, and it's also a more enjoyable learning experience.
Oh, cool. There is actually one question here.
Okay. So on sentiment analysis, could be a large language model with some few-shot learning have better results than old methods? So the brief answer to this is yes. The long answer is yes, but it's not. Even if you could have better results, it couldn't be the best choices for your project. What I mean is that generative AI is accurate, is performant, but there's some disadvantages like cost, for example, region availability that could be limited, or I don't know, simply the complexity of using it in your project. So it's a powerful, very powerful tool, but if you just need to have sentiment analysis in your project, it could not be the best fit. But let's say that, for example, you should combine different capabilities. So you don't need just sentiment analysis, but you also need question answering, or you also need, I don't know, content generation or another kind of task. At this point, it could be an added value that you have a single model performing different tasks. So again, yes, the short answer is yes. The long answer is that it's not the only accuracy or performance is not the only factor you should consider when you choose the technology, the best fit in terms of technologies for your project. I hope this helped and this didn't make like other confusion.
No, I think it was a great answer. I think like if you use OpenAI, it is really good in if you have different languages, and if you want to do sentiment, that is one kind of the model does it all for you, which is really cool. And now we're talking about demos, and like you in one call to OpenAI, you can do like multiple things. I have made a very small demo that if you send an email, it will kind of summarize that email for you, extract the action points, get the sentiment analysis, and then a logic app. If someone is not happy, it will just put an exclamation mark for me, like, Henk, you have to respond to that email. And that can all be done in like one prompt, in one OpenAI call. You don't have to call it like 20 times.
Yeah, that's a great example.
No. So let's have a look at the chat. No more questions. So then I think I'm going to thank you for your time, for being on the show.
It's a pleasure. Thank you, Henk.
And I will share all the resources with the video. Thanks so much. And everyone, bye-bye. Have a great day.
Bye-bye. Have a great day.